This question requires kids to be familiar with the numbers. So, which situation could make this happen? Namely, the sum of the digits of n is twice the sum of the digits of n plus 1. So let's look at the numbers. Assume two digits of this natural number n is a and b. Namely, n is equal to ab. Here, the ab doesn't mean a multiply b, but they just combine together. For example, if a is 2 and b is equal to 3, n is equal to ab, just equal to 23. Okay, so we look at the n plus 1 is just the b increased one number, so it becomes a b plus 1. For example, n plus 1 could become 24. So let's look at the equation. Look, a plus b is the sum of the natural number n is equal to the sum, twice the sum of the n plus 1, so 2 multiply a plus b plus 1. Then we can get a plus b plus 2 is equal to 0. Is it possible? No, this is impossible because a and b are natural numbers. And two natural numbers, the sum of the two natural numbers and plus 2 will never be a 0. So this scenario will never work. There's another situation is at the turning points. For example, is 29 to 30. So let's have a look at it. So which means n could be a9 and n plus 1 just a plus 1, 0, for example. Then we say, okay, this is a plus 9, it's the n, is equal to twice of the a plus 1 plus 0. Let's look at the result. So that means a has to be 7. If a has to be 7, b is 9. That means n is equal to 79, and n plus 1 is equal to 80. Then 7 plus 9 is 16, is twice of the n plus 1, the digital number is 8. So it's right, which means the sum of the digits of n shall be 16. The answer is D. But might some students will ask whether you just assume this two-digit number. Does it hold for 3 or more digits? Let's have a look. So we suppose n is equal to ab9, then n plus 1 is ab plus 1, 0. And let's see, a plus b plus 9 shall equal to 2 times a plus b plus 1 plus 0. What do we get? To meet the condition, a plus b has to be 7, which means n can be, for example, 169, n plus 1 is 170, and then or 259, and the n plus 1 is 260. So what does it mean? Does it mean to meet this condition, the sum of the digits of n does not change? It will be always 16. And 79 is the smallest possible n, because the other number is just bigger.